Okay, hello class. Sorry I'm not here again today, but I am in the building because I'm just at a professional development. Today we're going to work on section E, which starts in page 229 in your book. You can pause this at any time, and you can also play it back. I will post it on our classroom page so you can have access to this recording. I'm not going to summarize too much about what's already in the book starting on page 229 because I would like to apply the examples right away. I'm going to talk about this notation you see here with this sigma, and you'll get comfortable with those to be able to do it by hand for a non-calculator section or with the calculator in the second segment of these notes. So for the examples, we're just going to jump right into it. I came up with the two examples that are different from the ones that are in the book, so you have more examples to go off of. So for this example, we see the directions to write down an expression for S sub n, which means the sum of up to any amount. So when I say sum, it's adding these terms together. So this one would be the sum of 4 terms, or S4 with what I see right now. But it's asking for Sn. And so when I want n, it means the general rule. So we have our sigma, which means sum of, and then we're going to start with thinking about that if I do S sub n, then the n is up here. These numbers are going to agree. And this is saying start with the first term, and then this is the rule that I want you to apply. So for this example here, I have to come up with the rule. Now I know just because I've done this question that it's an arithmetic sequence, so we want to remember with an arithmetic sequence that we're going to prove the sequence by taking the new and subtracting the previous, keep spelling that wrong, previous, to make sure that it's the same amount each time. So in other words, 11 minus 3, is it the same thing when I do 19 minus 11? And it is. I get 8 each time. So I just proved that this is an arithmetic sequence, and now I need to come up with the rule. So for the rule, we would say u sub n equals u1 plus the common difference n minus 1. The common difference in this case is 8, so I'm going to replace this with an 8. And then n minus 1, I'm just coming up with a general rule, and then I'm going to substitute in the first term, which in this case is 3. So the rule u sub n is 3 plus 8 times n minus 1, and I'm going to want to simplify that. So this is 8n minus 8, but then I want to add that 3, so the rule that's going to go here is 8n minus 5. So when I'm talking about just S sub n, it's the general rule for the pattern that's here. I didn't know what the rule was, so I had to use my previous knowledge of arithmetic sequence to come up with the rule, and I put it there. So this is just the first part, the general rule. Now the second part of this question is to find the sum of the first 5 numbers. So here, if I'm going to write the rule, which we'll eventually learn in the calculator, I can get more specific with saying start with the first term. Now I'm going up to the 5th, and then I have my 8n minus 5. You will be learning different rules and ways to be able to answer this, but in a non-calculator section, you'd have to use the numbers. And so I can go through and find the first 5 figures either with my rule or the pattern that's here. So I have my 3 plus 11 plus 19 plus 27, and then I just need to come up with one more for the 5th, which would be our, where's my list? My 35. And when I add that all together, I get 95. So here's the notation to write about the sum of my series, and then here is the answer by getting it by hand. So in each case, I can substitute this, and this could be an n as well. This is technically because, so I could make that n to match this, or I could make it x, and then this could be x. So those numbers are what's matching, because this is your first term, and then your second term, your third term, your fourth term, and your 5th term. But when I add all those terms together, I get 95. Now in the next section of our notes, I will show you how to do this in the graphing calculator, because it'll do it in one step. But this is the notation that you'd have to come up with to be able to put it into your calculator. So this is not an exponent. This is just saying you can say 8x minus 5, or you could do n, whichever you want. I'm using x because that's the easiest translation into the calculator. In our next example, I know that this is geometric, and I could either test out with the arithmetic seeing that the difference isn't the same, But with geometric, I would now do new divided by previous to make sure I get the same common ratio. And when I do the new divided by the previous, I can do my 3 divided by 2, and I get 1.5, and just double check that I do 4.5 divided by 3, and I also get 1.5. So my common ratio is going to be 1.5. When I write that general rule, I would say u sub n equals my u1 times my rate n minus 1. So in this case, a u sub n equals the first term, which is 2, times the rate, which I found, 1.5, to the n minus 1. So now when I'm finding that first part, the s sub n, I'm going to have my sigma. And again, you can put an n or an x, whichever way you want. And then the, n up here. And then down here, when we're writing my general term, I can use an x starting with the first term. And then the rule goes here, 2 times 1.5 n minus 1. Now the second part, I want to find my s sub 5, so my fifth. So then I would have my sigma with a 5 up here. I'm starting with my first term with my rule. And then when I list my first terms, I have my 2 plus 3 plus 4 1/2 plus 6 3/4 plus 8 1/4, which I had to find, continuing the pattern, and I have 26 3/8. So that's how you would answer these general questions when it wants the s sub n. You're coming up with the rule, and then if it wants something specific, you apply it. Again, in just a little bit, we'll be taking a look at the calculator steps for that. Now the last example I want to go over is this expand and evaluate. So this is if I come up with my sigma notation first. So these are 2 different questions. And then if I have to do it by hand, what values does that represent? So notice they used some different variables here. So they said k equals 1. The 3 represents I'm going up to the third term, and the rule is that I'm going to multiply 4 to the term. So in this first one, what this stands for when it says to expand is 4 times 1 plus 4 times 2 plus 4 times 3, which is 4 plus 8 plus 12, or 24. So again, this tells me when to start, so the first term. This tells me the rule that I'm going to do each time, and this tells me to go up to the third one. Now in this second example, we have our sigma notation, and so this one is saying that k equals 1, so starting with the first term, going up to the 5th term, but now the rule is to do 11 minus 2 times the term. So now we're doing 11 minus 2 times 1, plus 11 minus 2 times 2, and then all the way up to the 5th term. So plus 11 minus 2 times 3, plus 11 minus 2 times 4, plus 11 minus 2 times 5. And when I simplify each of those things, I have 9 plus 7 plus 5 plus 3 plus 1, and that equals 25. So these are how you would do these in non-calculator steps. So I'm going to stop this recording now, and you can either practice some of these or just keep listening, and we'll play the next one, which will tell you how to do these questions with the calculator.